Let's take a look at this bond valuation problem where we're going to compare the semi-annual paying bond with an annual paying bond. Both bonds are of comparable risk. Now you might want to watch this one on full screen, and there's a little button on the bottom right that is similar to the button you'd see if you were watching a YouTube video and you want to expand it to full screen. So you might want to watch that. It may look clearer on your computer. All right, let me read the problem. Zumwalt Corporation's Class S bonds have a 12-year 1,000 par value and a 6.75% coupon paid semi-annually bond, and that is 3.375 each month. I probably should put a parentheses right there. Okay, those bonds sell at their par value. Now, Zumwalt's Class A bonds have the same risk, maturity, and par value, but the A bonds pay the same rate on an annual coupon. So see the difference? One's annual, one's semi-annual. Neither bond is callable, and we're asked to determine what price the annual bond will sell. Now, that's the answer there, but let me walk you through it. First, you could do the calculation for the semi-annual bond, but you really don't need to. And the reason why you don't need to is future value, it's trading at par, so the stated interest rate is going to yield a present value of the future rate. I'm not sure I said that correctly. The present value of the bond is going to be equal to the stated rate because it's trading at par. But let's put in these factors, and I'll show you how that works. You would use the present value function, and here I'll put it up right here. And then you'd say, well, what's the rate? Well, on the semi-annual bond, the rate is given by B5, which is the 6.75, divided by B6, which is 2. In other words, 2 times a year. So we get that 3.375, which you see right there. Okay, what's the payment amount? Well, the payment amount, again, I'm going to enter this as a negative so that my present value comes back positive. The payment amount is going to be $1,000 times the 6.75 divided by 2. And there you can see I've done the calculation there. So every 6 months we're going to pay $33.75. It's negative because it's a cash outflow. Then at the end of the life, we're going to pay back the full $1,000. Again, that's given in cell B4. I enter it as a negative. And when I hit enter, I get a present value of $1,000, which is what we would expect. All right, so what do we know? The effective value of the bond is the 675. The equivalent rate, if we were to compound that semi-annually, what you have to do is just determine what's the effective rate if it's paid semi-annually. And the easiest way I know how to do that is to use an Excel function called effect. Here's how it works. It returns the effective annual interest rate. So we tell it the effective rate is given in cell B10, the 675, and it compounds twice a year. So what would be the equivalent rate if that was the effective rate? And that would be 6.86. Okay, now that we have 6.86, we're going to use that to determine the present value of the annual bond. Future value is 1,000. Now, the stated rate, I'm going to be clear that that is actually stated. I'm not sure why that's not appearing as black. Let me change that to black. There we go. Okay, the number of periods is 2, number of years is 12. Let's look at how we would calculate that. Put this over here so you can see it. The rate is that rate there given in cell B11, right? The equivalent rate. Number of periods, 12. It's an annual bond. The payment amount is going to be equal B14. The future value times times the interest rate, the stated rate. So that's how we compute the actual payment. And again, I'm showing it as a negative because that's going to be a cash outflow. And then at the end, we pay back the $1,000 of the bond. So the only thing we've done different here is that we're using the equivalent rate that we computed, and we needed to do that in order to come up with the present value of the bond. So when I hit enter, I get 990.89, and that's how we solve this kind of problem.